Alright, so in the last lesson we looked at arrays a little bit, and in the lesson before that we looked at some of the rules for function and variable scope, and determined how functions have their own sort of local stack, where the variables that you declare inside a function stay local to that function. But today we're going to look at an interesting property of arrays and look how they kind of subvert that particular idea. So remember, generally, the variables that we declare inside a particular function stay inside that particular function. So if we want to change the variable, we either pass a argument and make some operation on it, and then return a new variable, or we have to declare it globally if we want it to be accessible in two functions. For regular variables like integers, floats, characters, this is the way it is. But let's take a look at what happens when we attempt to change an array that we pass to a function. So this is the program that we looked at in our last lesson. So we'll just grab the first element of the array, which should be 1 here, and we'll attempt to change it in this sum function. Let's have this return nothing. Basically, the void return type allows us to have a function that doesn't return anything. So we're going to call that function on this array now and see whether it actually changes the value. Before, in the previous instance, when we tried to do this, pass a parameter to a function and then change it within the function, it didn't work because of the rules of variable scope. But let's see what happens when you try and do this with arrays. So all we're doing is changing the first element of our array to 21 in that function and then printing out the result. So we'll see whether it's either going to be 1 or 21. So let's and then we can run it. And as you can see, instead of printing out 1, it printed out 21. So our array actually allowed us to change a value within another function without making it global or doing anything like that. So the reason why, when we go back and look at the code, is basically because of pointers, which is the concept that we're going to look at in this particular lesson. When we pass an array to a function, we are really passing a pointer as opposed to passing all of the values in the array itself. And basically, what pointers are a variable that holds a memory address of a particular location as opposed to a value itself. So we'll look at what that means. So understanding pointers requires to look in a little bit to how C works underneath. So each time we declare a variable, basically we're saying to store a particular value in a specific memory location. So when we declare an integer variable, we can actually print out the particular memory address that this is being stored in. We can use an operator like this to get the memory address of a particular variable. So we have a hexadecimal address for the particular variable. It's the location in memory that this variable's information is stored. So how this relates to pointers is, pointers are essentially variables that hold memory addresses. They point to particular places in memory where you can find information. So for example, we can declare a pointer like this. We use an asterisk to identify this variable as a pointer. And then we'll set it to point to the address of the variable that we declared above. So now we have a pointer to that particular variable. So we can access the actual value that's stored at this particular memory address, and we can access the memory address itself. So if we do what's called dereference the pointer and access what's stored at the address that it's pointing to, we can get the value. So let's print out the value that's stored at this particular pointer. So when we use the pointer like this with the asterisk, we are referencing the actual value that the pointer is pointing to and not the memory address. If we had used the pointer without the asterisk, we would be specifying the particular address that we're looking for and not the value. So let's print this out and take a look at what we get. So as you can see, when we use the pointer in that particular way, we get the actual value that we're pointing to and not the memory address itself. Since the concept of pointers can be difficult to understand, let's look at a little illustration of what's actually going on when we dereference a pointer. So we have our variable, in this case var1 that we declared, and it has basically an actual value and a memory address. So we know that it's stored at a particular place in memory, and we can access it. Whenever we access that variable, we look at that particular place in memory and get the value. When we use a pointer, that pointer contains a particular address in memory where we go get a particular value when we dereference it anyway. So in this case, point1, our pointer, holds the address of variable 1. So if we want to get the data stored in variable, or in that particular memory address, we can dereference the pointer, which looks up that memory address and returns to us the value. But the value of point1 itself is just the memory address of our particular variable. So there's a lot of different ways that pointers can be helpful to us when programming. One of the immediate ways that we can see is, since we get the direct memory address of a particular value, if we want to pass something to a function and then change it, with pointers we can, and we'll take a look at how. So before pointers, we attempted to write functions that changed the value of a particular variable, but they didn't work because we weren't directly accessing the variable. We were accessing a local copy of that variable within our own function. So now let's try and do the same thing, but correctly this time with pointers. So let's change this function to take a pointer as an argument rather than just a regular variable. So now we've taken a pointer as an argument, dereferenced the pointer, so we've accessed what the pointer is actually pointing to, and changed the value of it. And now let's pass that pointer to this function. And then print out the original variable. So even though we passed a pointer to our change value function, the value of the original variable, var1, will actually be changed in this case. So let's take a look at that. So as you can see, the value of our variable in this case is 11 as opposed to 10, because pointers allowed us to change the actual value of that variable by accessing it via the memory address, as opposed to attempting to create a local copy. So we looked at the basics of how pointers work, but this isn't really a practical use case or a reason why you'd really need to use pointers, because there are some situations in which pointers are necessary, and in the next lesson we're going to talk about how to dynamically allocate memory, and for that we're going to need pointers. So this is just a basic overview of pointers in C.